So you are welcome to today's class. So today I will show you how to draw the ring structures of your carbohydrates, okay, in an easy peasy way. But before you continue with this video, I hope you've watched the previous video on how to draw the linear structures, because that is what you are going to use to draw the ring structures also. So I hope you've done that. If not, please make sure you go back and do that now. So now for the ring structure, now for us to draw the ring structure, the first thing we need to draw is the what? The linear structure. So let us start with that of glucose. For glucose is a what? A 6-carbon monosaccharide, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the first thing you are going to do is what? Put your functional group for glucose and this. Close the chain at the bottom. CH to OH. We've explained all this, okay? So your functional group has already closed the chain at the bottom, so you don't have to at the top rather. So you don't have to put anything at the top again. The next thing you just have to do is to what? Apply your triangular law, which is what? OH here, OH here, and OH here. So this is the triangle. And this last carbon will determine whether it is what? Is it a D glucose or an L glucose? So because this structure we are dealing with what? D glucose. So the OH will be on the what? Right hand side. I hope that is clear. So the next thing is for us to convert this into a ring structure. So for me to convert this guy into a ring structure, this is the linear structure. So for me to convert it into a ring structure, I will not just convert it anyhow. I need to tell some guys about this, that alpha, we are about to convert this linear structure into a ring structure. I hope that is clear. So one of the first person I'm going to tell about this is what? The functional group. The functional group must be aware that we want to convert this guy into a ring structure. Okay, so we have to tell this functional group, this guy must be aware that we want to convert this linear structure into a ring structure. So apart from the functional group, which other person do you think we need to tell about is that we need to convert this into a ring structure? The other person we need to tell about this is the what? The last chiral carbon. Yes, the last chiral carbon is also what? An important guy here. I did not say the last carbon, I said the what? The last chiral carbon. And I hope you know what a chiral carbon is. We've explained that before, okay? So I need to tell this last chiral carbon about it. That is to tell you that what? The ring structure will be formed between the what? The functional group and the what? Last chiral carbon. I hope that is clear. So this is the functional group. This guy must be aware that we want to convert the linear structure into a ring structure. And this is the last chiral carbon. This guy must also be aware that we want to convert this linear structure into a what? A ring structure. So the next question is, do you think this last chiral carbon will go and meet the functional group, or the functional group will come and meet the last chiral carbon functional group, or the functional group will come and meet the last chiral carbon? Now this is it. The last chiral carbon have to go and meet the what? The functional group. Why? The functional group is the boss. So you don't expect the boss to come down all the way from here to here. No. This last chiral carbon have to go and meet the what? The boss. And tell the boss that, sir, we are about to convert this linear structure into a ring structure. Do you think we should convert this linear structure into a ring structure? Then the functional group can then what? Accept that. That is to tell you that the ring structure of any carbohydrate will be formed between the what? Functional group and the what? Last chiral carbon. I did not say the last carbon, I said the what? The last chiral carbon. And I hope that is understood. So now let us form the ring structure. So don't forget this last chiral carbon OH. This last chiral carbon will send its OH, this hydroxyl. It will send it to the what? To the what? Functional group. Go and tell the boss that we are about to convert this into a ring structure. Tell the boss about it. Okay? So we have this carbon 1, carbon 2, 3, 4, 5, and 6. Okay? This is the functional group. We have an hydrogen here. We have OH, our triangle, OH, 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 and CH2OH, hydrogen, 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 and hydrogen. But don't forget, this last chiral carbon OH is not there, is not here anymore. Where is it now? The last OH is now with the boss now. This guy is telling the boss that, hello sir, we are about to, sir, do you think we should convert this into a ring structure or not? So is that this guy, this is the OH now. He's talking to the what? To the functional group, which is the boss. Sir, please let's convert this into a ring structure. So the next thing is that what? The functional group will then accept, yeah, there's no problem. You can convert this into a ring structure. But before that, I think we should tell others about that. Okay? So this functional group will then send its own messenger, which is this oxygen. It will send it here. That okay, just announce to others that we are about to convert this into a ring structure. I hope you understand that. So it means that what, this oxygen will not be here anymore. The oxygen will then come down here, shouting to these guys. This oxygen will not come and meet this guy. It will not come and meet this one. It will not come and meet this one. It will not come and meet this one. This oxygen is the what? A messenger of the what? Of the functional group. That is messenger of the boss. Okay? So the boss has already sent its messenger that tell others that we are about to convert this into a what? A ring structure. So this is the messenger here shouting, we are about to convert this into a ring structure, and I hope that is clear. So this point and this point, that we remove something from them, we are then going to join them together with this oxygen. Okay? I hope that is clear. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. Now, let us do the ring. That is to, now for me, that's to tell you that what? The ring will be formed between just carbon 1 and carbon 5. Okay? So let us form the ring now. Carbon 1 attached to carbon 2, attached to carbon 3. Carbon 3 is attached to carbon what? Carbon 4. Carbon 4 is attached to carbon what? Carbon 5. And between carbon 5 and carbon 1, we have what? Oxygen. So carbon 5 and carbon 1, we have the oxygen. I hope that is clear. Carbon 5 is carrying what? This carbon 6 H2O. So this carbon 5, let me use the red. Yeah? Yeah. No worry. So CH2OH. Okay, this is the carbon 6. Okay, carbon 5 is on what? On carbon 6. Okay, so now let us put the OH. Carbon 1 is having hydrogen and OH. Okay, hydrogen and OH. What about this carbon 2OH, carbon 3OH, and carbon 4OH? So there's a way you are going to do that. You will not just put this OH anyhow. You will not just arrange them anyhow. There is a way you are going to arrange the OH. Okay? Now, let me tell you this. The best position to sleep is to what? For you to sleep with your what? Right hand side. Now look at this guy now. This glucose now. If this guy wants to sleep with its what? Right hand side, that's to tell you that what? I'm going to push this guy towards this side, right? So this guy is going to what? Sleep here. I'm going to push it so that it will sleep with its what? Right hand side like this. Okay, so if this guy should sleep with its right hand side, you will notice that what? The OH on carbon 2 and the OH on carbon 4 will be on the what? On the floor. They will be the base. OH on carbon 2 and OH on carbon 4 will be on the what? On the floor. While OH on carbon 3 will be at the what? Top. That is to tell you that what? Carbon 2 OH and carbon 4 OH will be at the what? Bottom. OH and OH. Why carbon 3 OH should be at the what? At the top. I hope that is clear. So this one we have hydrogen, this one we have hydrogen, this one we also have hydrogen, this one we also have hydrogen. I hope that is clear. So this is the ring structure of glucose. But that is not all. That is not all. You see this carbon 1. Let us look at the linear structure. We've actually done the ring structure. But I want to show you something. Let us look at this linear structure back. Okay? We've actually explained what a chiral carbon is, right? So, is this carbon 1 a chiral carbon? No, it is not a chiral carbon. And we understand why. Okay? What about this carbon 2? Is it a chiral carbon? Yes, a chiral carbon. Yes, a chiral carbon. Yes, a chiral carbon. What about carbon 4? It is also a chiral carbon. Okay. What about this last carbon, carbon 6? It is not a chiral carbon. Fine. But you will notice that this carbon 1 initially was not a chiral carbon. But here, it has turned to a chiral carbon now. It has hydrogen attached to it, OH attached to it, oxygen attached to it, and this attached to it. That's to tell you that what this guy now is a what? This carbon 1 now is now a what? Chiral carbon. But initially it was not a what? A chiral carbon. It means that what this guy will be a what? A special guy. Because initially it was not a chiral carbon, but during the course of the reaction, it later turns to a what? A chiral carbon. That is to tell you that what? This guy will be what? This guy will be what? A special guy. We need to what? Treat this guy special. And this is where the idea of alpha and beta glucose or alpha and beta carbohydrate comes in. This alpha, is it an alpha carbohydrate or a beta carbohydrate? This is where the idea comes in. And this type of carbon is known as what? Anomeric carbon. An anomeric carbon is a carbon in which initially it was not a chiral carbon, but it later turns to a what? A chiral carbon. And it is the one that will determine whether this structure is what? An alpha structure or a beta structure. So now, how are you going to know if it is an alpha or a beta? It depends on where this carbon 1 OH is. If the OH is at the bottom, it is going to be alpha or beta. If the OH is at the top, it is also going to be alpha or beta. So how are we going to know? So now this is the question we are going to ask. If I should ask you alpha, how are you doing? And you tell me that you are better, what does that mean? I said alpha and you said you are better, you are good. Now the word better means that what? You are not in the previous position you were before. You've actually what? Moved up. Alpha and beta now. That means you've already what? Moved up. That is to tell you that for the if the OH is at the top, that is what? A beta structure. Why if the carbon 1 OH is at the bottom, that is what? An alpha structure. Alpha, we don't even know how you are doing right now. Okay? I hope that is clear. Alpha and beta. So when you say you are beta, it means that what? The OH of carbon 1 is already what? At the top. I hope that is clear. So what structure is this one? This one is what? An alpha glucose. Why? The OH is at the what? Bottom. What if I put the OH at the top? OH. This one is what? A beta glucose. So let us name this guy. So what is this guy's name? This guy is what? Beta D. Don't forget that what we said, whether we are talking about a D glucose or an L glucose, it depends on where the OH is. For the last chiral carbon, when we talk about D or L, that one is what? Enantiomers, okay? So you are going to look at the last chiral carbon. If the OH is on the left, that is what? L glucose. If it is on the right, that is what? D glucose, okay? So this is, for this structure, it is what? Beta, okay? And it is also a what? A D glucose. It's quite super. But mind you, I made mention of chiral carbon, and I said chiral carbons are what? Carbons that has what? 4 different groups around it, right? The linear structure of glucose has that many chiral carbon. This is not a chiral carbon, but this is a chiral carbon, right? This is the second one is the chiral carbon, right? Chiral carbon. The third one, chiral carbon. The fourth one, chiral carbon. The fifth one, chiral carbon. The sixth one is not a chiral carbon, right? So the linear structure of glucose has that many chiral carbon? 4 chiral carbon. Now you notice that what? The carbon 1 of glucose does not have a chiral carbon. It's not a chiral carbon, rather, because it has oxygen, hydrogen, and everything. It only has 3 groups. But look at the carbon 1 here. It is now a chiral carbon. Why? It has hydrogen attached, OH attached, oxygen attached, and everything here attached. They are different things.
Hope it is clear. It has turned to a what? A chiral carbon now. It means that what? The ring structure of glucose, we have how many chiral carbon? Let's count. 1, 2, 3, 4, 5. The linear structure has how many? 4. The ring structure has how many? 5. And this carbon one will then be special. Why do you think the carbon one will be special? Because initially it was not a what? A chiral carbon. So it has to be special. We are going to use this for something. That is where the idea of alpha and beta glucose comes in, or alpha and beta carbohydrates, to be specific. Okay? And the carbon that is going to determine the alpha or beta is the what? Carbon 1. Why do we say we should choose carbon 1? Because initially it was not a chiral carbon. So we are going to choose carbon 1. And this carbon 1 is also known as what? Anomeric carbon. An anomeric carbon is a carbon in which initially it was not a chiral carbon, but it later turns to a what? A chiral carbon. From gas to what? To grace. So we are going to use this gas as the what? It will determine our what? Alpha and beta glucose. So which of them, if it is alpha, will the OH be at the top or at the bottom? This is where the question comes in. If I should ask you alpha and you reply me with what? I'm fine, or I am better now, what does that mean? Does that mean that what? You were in the previous position that you were before, or you've already what? Move up? It means you've moved up, right? You already what? Move up. I asked alpha, you said you are better. It means that what? You've already moved up. It means that what? For beta glucose, the OH should be at the what? Top. Very easy, very clear. But for the alpha, it should be at the what? Bottom, because alpha, we don't even know how we are doing now. I mean this alpha, okay? How far, which is still the same thing as what? Alpha. I hope you are good. So what type of glucose is this? A beta glucose. I hope it is clear. But this beta glucose is from the what? D glucose. So this is what? Beta D glucose. So this is what? Beta D glucose. What if I should put this OH here and I put the H here? This will be a what? Alpha D glucose. I hope it is clear. So this is what? Beta D glucose. Let's do the same thing for the structure of, I think, fructose. Okay, let's do for fructose, because fructose has another functional group, because you are still going to do something related to this for galactose. So I should not stress myself on galactose, because galactose and fructose have the same what? Functional group. So let me do for fructose that has a different functional group. Don't forget, we said fructose will not form the triangle, right? Why? Because the guy has been what? Bribed with what? Fruit. The same thing as what? Galactose. Galactose will not form the what? The triangle, right? Why? Because it has been bribed with what? Gala. So we don't forget that what? Your gala is a sausage roll, okay? Carb 3, 4, 5, 6. So fructose is a what? A ketose, okay? So it has its functional group here. You can see it's just like this guy is kissing here, okay? So this is what? A fructose. So we have our CH2OH here also CH2OH, that is OH, hydrogen, right? This, so now let us form our triangle. On the norms, we should have started forming all our triangle from the what? From the right. For all the glucose, you start forming your right angle, your triangle from the what? From the right. Okay, but you notice that what? This function, and on this you start from the what? Second carbon. But you notice that what? This functional group is already on the what? Second carbon. So I need to what? Move down to the what? Third carbon before I can start forming what? My triangle. But because I've already moved down to another carbon, I will not start forming a triangle from the what? From the right anymore. I will start from the left. So I will start forming my triangle like this: OH, OH, and OH. But because this is fructose, fructose also will not form the triangle. Instead of it to form the triangle, because this guy has been given a fruit, it will not form the triangle. So this is what? Fructose. A D fructose, to be precise, because the last chiral carbon has its OH on the what? On the right hand side. I hope that is clear. So If I want to turn this guy to a ring structure, the same thing will also happen here. The functional group and the what, and the most important chiral carbon, which is the fifth chiral carbon, we need to what, communicate. And for them to communicate, this OH, we have to leave here and go to the what, to the what, to the functional group. It's going to what, talk to the what, functional group. Hello boss, we need to convert this guy to what, to a ring structure. I hope that is clear. Then when the boss approves it, it will send its what, oxygen somewhere here and tell the oxygen to what, tell others that okay, we are about to what, form the ring. So we are going to have this CH2OH carbon 2 3 4 5 6 OH OH. But this OH is not here anymore. It has already what, come here to the boss. The boss asked oxygen initially, so the OH is here now. Okay, so he's talking to the boss. So the boss will now later send its own what, oxygen. It will send its oxygen what, somewhere here that tell others that we are about to what, form the ring. So this one we then also communicate. You know, this one as well, they already sent its what, OH here, so it will also form this with this. So the functional group and the carbon 3 4 5 we then form the ring. Now let's look at it. The ring is starting from what, carbon 2, because it is the functional group that is going to what, start the ring. The same way the functional group started, which is what, carbon 1, started the what, the ring here. This also functional group on carbon 2 will start the what, the ring here. Carbon 2, carbon 3, carbon 4, carbon 5. Then carbon 5 and carbon 2 are having what, oxygen between them. Why carbon 5 has what on it? CH2OH, CH2OH. I hope that is clear. Now, the next thing is all these OH. How do you think we are going to place them? Don't forget that what the best way to sleep is what, sleeping with your what, right hand. So I'm going to push this guy to sleep with its right hand. So I'm gonna what, I'm gonna push this guy. So what do you think will happen? This OH will be what, on the floor. It means that what, the OH on carbon 4 is on the what, is down. This OH on carbon 4 is down. Why the OH on carbon 3 will be what, up. So the OH on carbon 3 is what, up. You also will see it. So the next thing is carbon 2 has an OH, and it also has what, CH2 OH. So this is hydrogen, hydrogen, and hydrogen. Now you will notice that initially this carbon here, this, okay, now let's look at this fructose. How many chiral carbon does it has? How many chiral carbon does it has? This first one is not a chiral carbon. Why? Because of these two hydrogen. So the first one is not a chiral carbon. What about the second one? This second one is not a chiral carbon. It has oxygen 2 3. So it has 3 things attached to it. It is not a what, chiral carbon. What about the third carbon? Yes, it is a chiral carbon. This one also, it is a chiral carbon. What about this? Yes, it is a chiral carbon. But what about this? This is not a chiral carbon. It means that what, the linear structure of fructose has how many chiral carbon? 3 chiral carbons. 1 2 3. Now let's look at this guy. This carbon 2. You will notice that was the carbon 2 here. 1 2. It was not a chiral carbon before, but now it has turned to a what? A chiral carbon. It has OH, it has CH2OH, it has O, and it has this attached to it. So this is now a what? A chiral carbon, right? So this is what, a chiral carbon, and we don't, which is what, an anomeric carbon. We said an anomeric carbon is a carbon in which that what, initially it was not a chiral carbon, but it later turns to a what? Chiral carbon. Do you understand? So when it was in the linear form, it was not a chiral carbon. But when it turns to a ring, it turns to a what? A chiral carbon. So the ring structure of fructose, we have how many chiral carbon now? 4. The linear has what? 3. The ring will now have what? 4. 1, 2, 3, 4. I hope it is clear. So this guy will also be special. This carbon 2, it will be special. You will notice that for glucose, that is an all aldehyde. For glucose and all aldehyde, for glucose and all aldehyde, their anomeric carbon is always on the what? Carbon 1, because that is where their functional group is. But for fructoses and other ketoses, their anomeric carbon is on carbon 2, because that is where their functional group is. Don't forget, anomeric carbon is the carbon that was initially, it was not a chiral carbon, but it later turns to a what? Chiral carbon. I hope it is clear. So we have it here. So this guy will also be what? Special, because initially it was not a chiral carbon. So don't forget our alpha and beta now. So alpha and beta. Beta means the what? The OH is at the what? At the top, because you are beta now. So the OH at the top. So this will be what? A beta D glucose. This is D beta D fructose. I'm sorry about that. So beta D fructose. I hope that is clear. So the next thing now is to move into the what? The structures of our what? Disaccharide. Okay. So don't forget that disaccharide means what? They have two what? Monosaccharides. In disaccharide, we have two what? Monosaccharides coming together to form a. So now let us move into the disaccharide. So what are the disaccharides? These disaccharide are basically carbohydrates with what? 2 sugar molecules. That is, these are carbohydrates with 2 monosaccharides. Okay, and our main disaccharide are the what? MLS. That is the medical laboratory science. You can take them as what? MLS. That is the medical laboratory science. The M is for the what? Maltose. L is for the lactose, and the S is for the what? Sucrose. Please always remember this, because I'm still going to use this for something very soon. Okay, and if you don't want to take it as MLS, you can take it as malt lac sucrose. So there's no sucrose in what? In malt. So don't forget, we said they have 2 molecules of what? Monosaccharide in them. So maltose is made up of what? Glucose and glucose. Lactose is made up of what? Glucose and galactose. Sucrose is made up of what? Glucose and fructose. These things are not actually hard to know. Just remember that what? All of them have what? Glucose, glucose, glucose. Okay, but for sucrose is what? Is sweet. This is your table sugar, so it should have what? Fructose. Don't forget that what? Fructose is found in what? In fruit. Okay, so sucrose should be made up of what? Glucose, then what? Fructose, that is fruit. It is found in what? Fruit. So the next one is lactose. It is made up of what? Glucose, then galactose. You can see the name here also in galactose. So lactose has what? Galactose in it. Okay, and all of them also have what? Glucose. The next one is what? Maltose, which is made up of what? Glucose and glucose. Okay, now don't forget, we said disaccharide involves what? The combination or the reaction between what? 2 monosaccharides. And by the time these 2 monosaccharides react together, one monosaccharide, which is a glucose, with another monosaccharide, probably like another glucose, when they react, okay, they are going to form what? The disaccharide. But during this course of reaction, something will be what? Will be lost. Something will be what? Something will be lost. And this is known as what? A type of what? Condensation reaction. What is a condensation reaction? A condensation reaction is the reaction between 2 or more molecules, okay, in which these 2 molecules join together and they lost a molecule of what? Water or ammonia or any other thing. So condensation reaction involves what? The reaction between 2 what? Molecules or more with the loss of what? Water. So now let us look at this. Now you notice that if I have something like hydrogen reacting with chlorine, okay, we are going to get HCl, right? And you will tell us that, okay, the type of bond between hydrogen and chlorine is what? a covalent bond. It means that if two molecules of monosaccharide should react together also, there will be a what? A particular type of bond between them. Me having a glucose reacting with what? Another glucose. Okay? We have a particular what? Type of bond between them. The same thing, the same way the bond between hydrogen and chlorine is what? A covalent bond. And the bond between what? Sodium and chlorine is what? An ionic bond, right? This bond is different from this. It means that what? If I have galactose and glucose also, the bond between them will be different from the bond between what? Glucose and glucose. I hope that is clear. Let me take that again. You know, if I have hydrogen and chlorine coming together to react, I'm going to get a what? A type of bond between them known as what? Covalent bond. Also, if I should react sodium and chlorine together, I'm going to get a type of bond between them known as what? Ionic bond. That is to tell you that for disaccharide too, when the two monosaccharides react together, they are going to form a type of bond. But the bond between what? Glucose and glucose will be different from the bond that will be found between galactose and glucose, which will also be different from the one that will be found between what? Glucose and fructose. I hope that is clear. So for the maltose, the bond that is found between the glucose and glucose is the what? Alpha bond. Okay? Alpha. For the lactose, it is what? Beta bond. Beta. While for the sucrose, it is what? Alpha beta. You can see that was why I said you should just arrange these guys as the what? The medical laboratory science, that is the MLS. So you just write your alpha, beta, and then the last one will be what? Alpha beta. I hope that is clear. So this is what? Alpha glycosidic bond, beta glycosidic bond, and alpha beta glycosidic bond. I hope that is clear. So let us draw the structure and see the alpha glycosidic bond and the likes. So let us start from the maltose. That means we have two molecules of glucose. So you should be able to draw your ring structure by now. C1 for glucose. Glucose is an aldehyde, right? So the functional group will start from carbon 1. C2, C3, C4, C5. Between the C5 and the C1, we have what? Oxygen. Okay. On the C5, we have CH2OH. And don't forget, when we put your what? Your linear structure glucose what? Down. For you to sleep on the right hand side, you will notice that the carbon 2OH is on the floor. And the carbon 4OH is also what? On the floor. That is at the bottom. Okay. While carbon 3 is what? At the top. So this is what? Glucose. A D-glucose, okay? So the carbon 1 is the what? Anomeric carbon. The carbon that was initially, it was not a chiral carbon, but later turned to a what? A chiral carbon. So this is what? We have OH attached to it. If the OH is at the top, that will be a what? A beta glucose. While if the OH is at the bottom, that will be a what? An alpha glucose. But don't forget, we've already seen is that what? For us to form maltose, we need two what? Glucose. And the type of bond that is found between the maltose is what? Alpha glycosidic bond. It means that what? This first glucose should be and what? An alpha glucose. I hope that is clear. It means that what? GOH will come to the what? Will be at the what? Bottom for this carbon 1 and H at the top. So because it involves what? Two glucose, so I have to draw the other glucose here also. So now let us draw the second glucose, right? Because we said for maltose we have two glucose molecules. So C1. So we have C1, C2, C3, C4, C5, and between the C5 and C1, okay, we have oxygen. On the C5, we have CH2OH there, okay. Now, for glucose, The carbon 2 and carbon 4 OH, we have them to be on the what? On the ground, OH, that is at the bottom, OH. Why for carbon 3, we have it to be at the top. I hope that is clear. So we have hydrogen here, hydrogen here, hydrogen here. So for the carbon 1, that is the anomeric carbon. So our OH will be at the what? Bottom, and hydrogen at the top. So now these guys are going to react together. Okay, these two guys are going to react. So how do you think they are going to react? Don't forget, we said a condensation reaction is a reaction in which what? Two molecules what come together, that is, they react together, and a water molecule is what? Lost, or sometimes ammonia, as the case may be. So looking at these two guys now, if they want to react, which side do you think will react? This carbon 1 of this one and carbon 4, you can see they are what? Close to each other. So this guy will react with what? This guy. I hope that is clear. So that is where the reaction will come from the carbon 1 and the carbon 4. Okay, and this OH and this OH will come together to give us what? Water. This is where we are going to get our water from. Our water is what? H2O. So H2O. So this is OH and O. So it remains one more what? Hydrogen for this guy to form what? Water. So I'm going to remove one hydrogen from here and add it to this. This is what I'm saying. If this guy OH come here, the OH is here now. So this hydrogen will come here, and this will be what? H2O. I hope that is clear. So it means that what? The OH is not here anymore. The hydrogen here has been what? Removed. I hope that is clear. So the only thing that will be left here is this what? Oxygen. And the oxygen will be what? Find between the two what? Molecules. And that is all. So I'm just going to draw this carbon here. You can draw everything actually. Carbon, hydrogen, okay. This one also carbon 4, carbon 1, hydrogen. The OH here is not there anymore. This one has what? Oxygen. So this is the bond. Don't forget, we have oxygen. We have something here also. This one also goes this way. I hope that is clear. So OH, OH, take hydrogen from here, take hydrogen from here. So you understand why this is called an alpha carbon, an alpha bond, because the alpha OH, this OH that is reacting here is what? An alpha OH. This OH is what? An alpha. Okay. So the bond is called what? Alpha. The bond is between what? Carbon 1 and carbon 4. So alpha 1, 4. Glycosidic bond. I hope that is clear. Also, let us draw for galactose. So the next thing for us to do now is to move to the structure of lactose. So how are we going to draw the structure of lactose? You will notice when I drew the structure of maltose, we have two glucose, right? The first glucose and the second glucose. But you did not know the first one I drew because both of them are what? Glucose 1 and glucose 2. So you can't actually differentiate that, okay, it gives this first and it gives this to be the what? To the second one. So now the question is, how are we going to draw the structure of lactose? It is actually very simple. So are we drawing the glucose first or the galactose first? Actually, we are drawing the galactose first. Don't scare yourself. From the name lactose, you should know that, okay, this is lactose, and from the word galactose, so removing the G, it means that what? For the structure of lactose, we are drawing the what? Glucose structure first, then the glucose structure. I hope that's clear. And for the MLS, don't forget, I said you should take them as what? MLS, the medical laboratory science, which are the what? The bond here is what? Alpha. The bond here is what? A beta bond. Why the bond here is what? Alpha beta bond. So for maltose, we have glucose and glucose. Okay, you can draw any of the glucose first. For lactose, you need to draw the what? Glucose first, then the what? Glucose. Why for the sucrose, you draw the what? Glucose first. So the only one you are drawing the galactose. The only one in which you are not drawing the glucose first is the what? Lactose. And from the name, I hope that is clear. So now let us draw the structure of our galactose. So for the galactose, we have carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and between the carbon 5 and carbon 1, don't forget we have what? Oxygen. So this is the structure of galactose. So don't forget that what? For glucose, if glucose should sleep with its right hand side, the OH that will be on the what? On the floor, that is at the bottom, will be what? On carbon 2 and carbon 4, right? Why for galactose, the one that will be at the bottom is what? Carbon 2. Why for fructose, the one that will be at the bottom is what? Carbon 4. So don't forget that, okay? So this is galactose, right? So this is galactose. The OH will be on what? Carbon 2. The one that will be at the floor will be on what? Carbon 2. While other will be at the what? At the top. OH and OH. Why for the carbon 5? The carbon 5 is carrying what? CH2OH. Please don't forget CH2OH. CH2OH. Carbon 1 is what? Anomeric carbon. Anomeric carbon is what? A carbon in which initially it was not a chiral carbon, but during the course of the reaction, it later turns to a what? A chiral carbon. And this is the anomeric carbon, right? It has turned to a what? A chiral carbon here. So now the other thing that this guy will determine is that what? Okay, is it a beta or what? An alpha? Okay. So this galactose that we want to draw here, are we drawing a alpha or an alpha or a beta galactose? We should draw a beta galactose. How did I know? Don't forget what I told you. I said you should take this MLS. Okay, the bond here is what? Alpha. That was why in the structure of maltose, the glucose was what? An alpha glucose. For this is what? Beta. It means that what? This galactose should be a what? A beta glucose. Okay. So for beta, alpha and beta. So because you are beta, you should be at the what? At the top. So I have this guy here at the top. I have the OH at the top. OH at the top and hydrogen here. And I hope this is clear. So the next one is the structure of the what? Glucose beside this. So let us draw the glucose beside it. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and between carbon 5 and carbon 1, we have oxygen. The carbon 5 is carrying what? CH2OH. CH2OH. So for the structure of glucose, our carbon 2OH is at the floor, and the carbon 4OH is also what? At the floor. And I hope that is clear. So this one OH will be at the top, right? It will be at the top. So don't forget we have hydrogen here, hydrogen here. I just did not write it, okay? So just make sure you put your hydrogen. So hydrogen, 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 here also hydrogen. I hope that is clear. So this glucose can be anyone. It can be what? An alpha glucose or a beta glucose. Why? Because this end is not reacting. So it can be flipping between alpha or beta. So you can put either alpha glucose there or a beta glucose. I hope that is clear. So let us just put anyone. Let us put the alpha or beta, anyone you feel like putting there. So we can have the OH here and hydrogen here, or put the OH here. So this is what? An alpha one. So now let us do the bond here. So in the bond, what and what are reacting? This OH here and this OH here. So we are going to remove what? Water from them. So this OH here, it will come down here. OH will come down here, and I will take what? An hydrogen from here. Okay? So this one will then give me what? H2O. I hope that is clear. Take the OH here. This is it. And just pick hydrogen from here. This is it. So this is what? OH plus H. That is what? H2O. I hope that is clear. And we will be left with what? An oxygen here. So it is the oxygen that will not be found between these what? So guys, don't forget this is what? Carbon what? Carbon 4. So the OH that reacted here is what? a beta OH, right? It was the full OH here that reacted, and it is what? A beta OH. That is why we call this guy what? Beta bond. I hope that is clear. And it is beta what? It's between what? Carbon 1 of this and carbon 4 of that. That is why we call this bond what? Beta 1, 4. I hope that is clear. So now, I don't want to, you can just try to draw this again, okay? Let me just show you, okay? I'll just draw this end and this end. That is all I'm going to show. So, for here we have carbon 1. The OH is not there anymore, right? Here we have carbon 4. Okay? We have an hydrogen here. Here we have hydrogen. And we have oxygen between them. This oxygen, this is the remaining oxygen will be found between these two guys, okay? So this is the remaining oxygen. Okay? This one has oxygen attached to it here. It has carbon 2 attached to it here. What about this? It has carbon 5 attached to it here, and it has what? Carbon 3 attached to it here. So this is the bond that we actually need here. So this bond. So this is the bond we need. I hope that is clear. And the bond is what? Beta 1, 4. I hope that is clear. So the next, okay, now the next thing for us to do now is to move to the structure of sucrose. Yeah. So let us do that now. So for the structure of sucrose, which one are we drawing first? We are drawing the glucose first, okay? In the MLS, we are always drawing the what? Glucose first, except for what? Lactose. And from lactose, don't forget that we do say what? Galactose. So just remove the ga. You have lactose. That is to tell you that what? For the structure of lactose, you draw your what? Galactose first. I hope that is clear. So the next one for us to draw now is this sucrose. Okay? So don't forget your MLS. Always have that in your mind. Your medical laboratory science. So this is what? Maltose, lactose, and sucrose. This will be what? Alpha, beta, and alpha, beta. And this alpha, beta is what? Alpha 1, beta 2 bond. And we've seen that what? These two guys are what? Alpha 1, 4, 1, 4. And this beta is also what? 1, 4. So we view this. The bond for maltose is between what? Carbon 1 and carbon 4. For lactose, between carbon 1 and carbon 4 of the different monosaccharide. So now for the sucrose, we want to draw for the sucrose. How are we going to do that? Now this guy is telling us that what? The bond should be between what? Carbon 1 of a particular monosaccharide and carbon 2 of another monosaccharide. I hope that is clear. So now how are we going to draw that? So don't forget that what we said, sucrose is made up of what? Glucose and fructose. Glucose and fructose. And we are always drawing the glucose first. So let us draw carbon 1. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and between carbon 5 and carbon 1 we have oxygen, okay? For the structure of glucose, the carbon 2 OH is at the what? At the floor, sleeping on the floor, and carbon 4 OH is also at the what? At the floor. So carbon 3 will be at the what? At the top. Don't forget we have hydrogen here, hydrogen here, hydrogen, and carbon 5 is carrying what? CH2OH and hydrogen here. So this is the anomeric carbon. So it can either be a what? A beta anomeric carbon, or a what? Or an alpha anomeric carbon. So the next one is the structure of our fructose. So the next thing for us to do now is to draw the structure of fructose. Okay. So how do you even draw the structure of fructose? I hope you've not forgotten. We have 1, 2. Have this. Let me use the other marker. We have carbon 1, carbon 2, 3, 4, 5, 6. Okay. Fructose is a ketose. It is kissing, okay? So the kissing will not be done outside. It will be done what? Inside. So on the second carbon, that is where the chiral carbon will be. Cover the chain at the bottom. Cover the chain at the top also. And also, don't forget, let's start forming our triangle. On a norm, we should have started forming our triangle from the what? Second carbon, and on the right hand side. But here, the functional group has already occupied the second carbon. That means that what I need to what? Move down to the next carbon. I hope that is clear. So, and when I move down to the next carbon, I will start forming the triangle from the what? Left hand side. Okay? Triangle. And the last OH here, this is what we are supposed to have, but because of the name fructose, this guy has been given a fruit, so it's going to betray us the OH here. I hope you still remember this thing. Please don't forget, I have actually explained everything in what my last video. So don't forget that was the last chiral carbon OH. We move to this what? Functional group. So this is the last chiral carbon OH here now. So, and this oxygen here is going to what? Communicate with everybody. We've explained all this. You will notice that what? It is only the what? Carbon 4 OH 2, 3, 4, 5. If this guy should sleep with its what? Right hand side, it is only the carbon 4 OH that will be on the what? On the floor. I hope that is clear. And our cyclic structure will not start from carbon 1, it will start from what? Carbon 2 to carbon 5. Because the OH is found between carbon 2 and carbon 5. I hope that is clear. So let us do that here now. Carbon 2, carbon 3, carbon 4, carbon 5, oxygen. I hope that is clear. Carbon 4 is having OH at the bottom, while all this one OH is at the what? At the top. At the top. No, don't forget that what? Carbon 5 is having CH2OH. Don't forget that. CH2OH and hydrogen here, hydrogen here, hydrogen here. Our carbon 1 we also have what? CH2OH and OH. Okay? CH2OH and OH. But now, see, don't forget our MLS, the medical laboratory science, MLS. We've already said that what? For maltose, it is what? Alpha bond, beta bond, and this one is what? Alpha 1 and beta 2. It means that what? For the structure of sucrose, the first guy should have what? Alpha 1. It means that what? The OH should be at the what? Bottom for alpha. While the next one should have what? Beta 2. The OH should be at the what? At the top. Beta. It should be at the top. And the bond should be formed between the what? The alpha 1 and the beta 2. I hope that is clear. It should be formed between the what? Alpha and the beta. Now, if the alpha is here and the beta is here, can they communicate? No. These two guys will not be able to communicate with each other. That is to tell you that I should not put the structure of fructose here. I should bring it down here so that the carbon 2 will be able to communicate with the what? Carbon 1 here. The structure already said what? Alpha 1, beta 2. It means that what? The bond is between what? Alpha 1 of carbon 1 and beta of what? Carbon 2. So it means that what? The next carbon, that carbon 2 should be here. So that they will be able to what? Communicate here. I hope that is clear. That means for the structure of sucrose, when you draw the glucose, put the next what? Fructose here. So let us do that now. Carbon 2, carbon 3, carbon 4, carbon 5, and between carbon 5 and carbon 2 we have what? Oxygen. Carbon 5 is having CH2OH on it. It is only carbon 4 that has its OH to be at the floor. Don't forget, this one OH is what? At the top. And our carbon 2 is also having what? CH2OH and OH. CH2OH and OH. So now don't forget that what? The bond is what? Alpha, beta. Alpha 1, beta 2. The first one is what? Alpha. The next one is what? Beta. That is the meaning. And this one is what? On carbon 1 and carbon 2. So how are we going to do that? It means that what? This guy should be an alpha OH. So the OH should be at the bottom. The OH for this guy should be at the bottom. So I have the OH here at the bottom. For the beta 2, the next one should be a what? A beta 1. The OH should be at the what? At the top, not at the bottom. I hope that is clear. So the OH should be at the top, and the CH2OH should be at the what? Bottom. Now, so that there is a reason for that, so that these two guys will be able to what? Communicate now. That is to tell you that this alpha should not be an alpha 1. Yeah, I mean, that is to tell you that this should not be a what? A beta glucose. Why? Had this been this guy is a beta glucose, it means that what? The OH should be at the what? At the top here. These two guys will not be able to communicate. And let's assume this one was a what? Was an alpha 1. They will not be able to communicate also. So this one should be a what? An alpha. Why this one should be a what? A beta, so that the two guys will be able to what? Communicate. I hope that is clear. So the next thing for us to do now is to what? Form the water from here, the H2O. Sorry. I hope this thing is very clear. So let us form our water. The OH here plus hydrogen from this one. So we have our what? Our OH2O. We have our H2O. I hope that is clear. So the next thing for us to do now is we've actually removed the water. OH is not here anymore. I don't want to withdraw this thing, okay? OH is not here anymore. Hydrogen has been removed from this, okay? It means that what? We are left with what? Just a single oxygen. Now the oxygen will be what? Formed between the what? Between the two guys. The oxygen, this and this. And this is what? 1, 2. Alpha 1, beta 2, glycosidic bond. And also, let me just tell you this. All these maltose, lactose, and the sucrose, you will notice that what? We do have oxygen between the two molecules. This alpha glycose, all these glycosidic bonds are also what? A type of what? Ether bond. Don't forget that what? Ether. We don't actually need that here. CH3O, CH3, methoxymethane. Okay. So that's the end of it. That's the end of today's class. So thanks very much for watching this and listening to me. So don't forget to subscribe to the channel, like and comment and share to your friends. Thank you.